Hello everyone, welcome to my class. In today's class, I'll cover area of surface of revolutions. So let me start the class right away. The key in this section is we are revolving a curve given by y equals to fx, x between a and b. That is, we are revolving an arc length, not an area. So first definitions. A surface of revolution is a surface obtained by revolving a plane curve y equals to fx, x between a and b, about the axis of rotations. And note that the surface area is the area of outer layer of the solids. There are two cases: when we revolve the curve about x-axis and when you revolve the curve about y-axis. Formula: when you revolve the curve about x-axis, then our formula is denoted by s and is defined by s equals to definite integrals from a to b of 2 pi y ds. So our integration is with respect to arc length. And 2, when you revolve the curve around the y-axis, then our surface area formula is s equals to definite integrals from c to d 2 pi x ds, where ds is under the radical 1 plus dy over dx outside is square times dx, or ds equals to under the radical 1 plus dx over dy outside is square times dy. And this expression we derive in our preceding sections. Great. Now let me go over the idea how we got those formulas. First, revolving around the x-axis. First, let me scroll down. First, revolve a small piece of length delta s of the curve given by y equals to fx bounded in AB about the x-axis. So then here in the first diagram, given function is y equals to fx, which is bounded between x equals to a and x equals to b. And we take a small piece of the curve and then we swing around the x-axis. Then in the second diagram, it generates a band or ring here. Okay. In the third diagram, let's flatten out that band. Let's cut somewhere and flatten out the band, and then this gives me this rectangular shape here. Now let's find the area of this rectangular shaped band. So again, back in the second diagram, on that band, what is our circumference here? The circumference is 2 pi times the radius. What is my radius here? Radius is the distance of this piece from axis of rotations, which is y. So in the third diagram, then our length of this rectangular piece is 2 pi times radius. Radius is y, so 2 pi y, and the thickness is delta s. So the area of this rectangular piece is 2 pi y times delta s. Great. And then now to find the total surface area, we are adding those areas here, right? That means we are taking definite integrals from a to b. So that's the idea. So the surface area generated by revolving the curve y equals to fx between x equals to a and x equals to b is denoted by s and is defined by s equals to definite integrals from a to b 2 pi y ds. That's the formula, right? 2 pi y, and this becomes ds. Similarly, when we rotate the curve around y-axis, then our formula is exactly the same idea. S equals to definite integrals from c to d 2 pi radius times ds. 2 pi x ds, where ds is given above. Awesome. Now let's move on. In general, if rotation is about the line y equals to k, then our formula is here, exactly same as what I talked earlier here. So this under the radical expressions is a ds, and here if we rotate around the x-axis, then y equals to 0, so we only have definite integrals of 2 pi y. And in the second case, again under the radical term is a ds term, and if we rotate about y-axis, then this becomes x equals to 0, which you already found this formula above. Great. So now with this idea, now let's do some example here. So first example, find the surface area of the surface obtained by rotating the semicircle given by y equals to under the radical r square minus x square around the x-axis. So on this equation, if you square both sides and simplify, this gives you x square plus y square equals to r square. So that's a circle of radius r, center at origin. So let me begin the solutions. So it's a circle, and we are rotating this upper half, means on this semicircle, this length, this arc length toward the x-axis. So here this circle meets x-axis at minus r and r. So here y equals to radical r square minus x square, take the derivatives, which turns out to be negative x over radical r square minus x square. Keep in mind that r square is constant. Okay, so let's use the formula. So begin the solutions. Let me scroll up. Yep. So the formula is definite integrals from x equals to negative r to r, then 2 pi y ds. That's better. So y is given, I can pull the 2 pi outside, so y equals to radical r square minus x square, and ds is by formula under the radical 1 plus the derivative is square times dx, and the next step equals 2 pi as it is, definite integral as it is, r square minus x square under the radical as it is, and then here we plug value dy over dx equals to negative x over radical r square minus x square outside is square here times dx. Great. And then let me scroll down. Then let's simplify here. So first take the LCD. So that means multiply 1 by r square minus x square and simplify. It only gives you under the radical r square over this r square minus x square. So then this denominator cancel to this numerator. Then only we have under the radical of r square. So square and radical cancel, so only r left. So only r left. The 2 pi as it is, definite integral as it is, and dx. I hope this computation makes sense to you all. And take the integration of r with respect to dx, simply r times x, 2 pi as it is, and x limit minus r to r. Put x equals to upper limit, put x equals to lower limit, and simplify. It gives you 4 pi r square. And yes, we know that the surface area of a sphere of radius r is 4 pi r square. Right? Great. So let's move on. Example 2. Find the exact area of the surface obtained by rotating the curve y equals to x cubed, x between 0 and 2, about the x-axis. So here, y equals to x cubed is this curve, bounded between x equals 0 and 2, and we are rotating this arc length around the x-axis, and this generates this shape here. Awesome. So let's use formula to find the surface area. First, take the derivatives of the given function. So here y equals to x cubed, take its derivative with respect to x, gives us 3x square. So let's compute this expression. This expression we use to compute the ds. So 1 plus y prime square equals to 1 plus 9x to the power 4. Hence, the surface area S equals to the definite integrals from x equals to 0 to 2 to pi, this is the y which is radius, times ds. ds is under the radical 1 plus the derivative square, which we computed here, 1 plus 9x to the power 4 outside dx. Now this integral is in terms of x, so let's write this y equals to x cubed in the next step. This gives me 2 pi constant pull outside, definite integral 0 to 3 as it is, x cubed, and I copied the second expression here. This radical becomes power 1/2. Great. And this integral, the x integral, is a good candidate for u sub. Let's put u equals to 1 plus 9 x to the power 4. The next step. So that's better. Put u equals to 1 plus 9 x to the power 4. Take the derivatives. So du equals to derivative 1 is 0. So keep 9 as it is. Derivative x to the power 4 becomes 4x cubed. So 4 times 9 is 36x cubed dx. And from here, solve for x cubed dx. So divide both sides by 36. Then we have x cubed dx equals to du over 36. Then let's rewrite this integral in terms of u. Then this becomes 2 pi constant as it is, integral as it is. At this time I don't care this limits here. And this expression is u to the power 1/2, and x cubed times dx becomes du over 36, which is our next step here. Great. Then take the integral of u to the power 1/2 with respect to u. So 2 pi over 36 becomes here pi over 18. To cancel 36 18 times. And integration of u to the power 1/2 becomes u to the power 1/2 plus 1, which is 3/2, divide by 3/2, which is same as multiplying by 2/3, that 2/3. And the next, let's resubstitute the variables. So put u equals to 1 plus 9x to the power 4 back again, and evaluate x equals 0 to 2. Let me scroll down. And simplify these expressions, putting x equals to 2 and x equals to 0. Then it turns out that the surface area is pi over 27 times 145 outside power 3/2 minus 1. Great. I hope this comparison makes sense to you all. Let's move on. Example 3. Find the exact area of the surface obtained by rotating the curve. Curve is given here. With the y bounds, y between 1 and 2, about x-axis. Solutions. Let's take the derivative of these functions. Now this derivative is with respect to y, so dx over dy equals to, you take the derivative here, use chain rule, then simplify. It gives us y times radical y square plus 2. Then find these expressions. 1 plus dx over dy, outside is square, so this expression goes to the value of ds later. This equals to 1 plus this y square plus this y square, and radical cancel, so only y square plus 2, FOIL, and this 3 terms turns to this binomial square. Great. So the expression of ds equals to, under the radical of this expression, left hand side, times dy. So then is square and this radical cancel here. This square and this radical cancel. So simply ds equals to then y square plus 1. Great. Hence, let's use formula. Hence, our formula is surface area equals to definite integrals y runs from 1 to 2 pi y ds. So then this equals to 2 pi, definite integrals 1 to 2 y as it is, and the ds is y square plus 1 times dy. First FOIL y inside, and then take integration with respect to y. It gives you 2 pi constant as it is. So y cubed, integration is y to the power 4 over 4 plus y times 1 is y. So integration is y square over 2, and the limit is 1 to 2. Put y equals to upper limit, put y equals to lower limit, and simplify. Our final answer is 21 over 2 times pi. Awesome. Let's move on. Example 4. Here, set up only an integral for the area of surface obtained by rotating y equals to e to the x between 0 and 1, about the x-axis. So its solution is, our formula is s equals to definite integrals x equals 0 to 1, 0 to 1, 2 pi y ds. ds is under the radical 1 plus dy over dx outside is square times dx. We know the derivative of ex is itself. So in the next step, 2 pi pull outside the integrals. Integral 0 to 1. Y is ex, so ex times 1 plus ex square. That means e to the power 2x dx. So it only says setup only. Great. Let's move on. Example 5. Find the exact area of the surface obtained by rotating the curve y equals to 1/3 x to the power 3/2 x between 0 and 12 about the y-axis. Great. So solutions. I'll take the derivative here. So y prime equals to, this is 1/3 times 3/2 being as a coefficient, so 3/2 times x to the power 3/2 minus 1, which is 1/2, and then 3 cancels, so simply 1/2 left. So y prime equals to 1/2 times x to the power 1/2. I hope this derivative makes sense to you all. Then find this value of these expressions. 1 plus y prime is square equals to 1 plus x over 4, right? So 1/2 square is 1/4. X power 1/2 is square is simply x. Thus, our formula is, for the surface area, s equals to the definite integral x equals to 0 to 12. That's the limit given to us. 0 to 12, 2 pi. Then we are rotating about y-axis, so our radius is x times our ds is radical 1 plus y prime square outside dx. Great. In the next step, pull 2 pi outside the integrals and then definite integral 0 to 12. This x as it is because I am integrating with respect to dx, and 1 plus y prime square we computed here, which is 1 plus x over 4, still under the radical as it is. Next step, let me scroll down. Now this is here, let's simplify this one inside the radical. So that means I can take the LCD 4 and multiply 4 and 1, so this means 4 plus x as it is here, and radical 4 bring outside becomes 2, so x over 2 here. So then this integral is a good candidate for u sub. So put u equals to 4 plus x, take its derivative, du equals to dx. Also solve for x equals to u minus 4. And also change the limit from this x limit to the u limit. It turns out that u equals to lower limit 4, u equals to upper limit 16. Then rewrite this x integral in terms of u integral. So here this 2 we can cancel, so simply pi constant outside, and then the definite integrals, the u limit, u equals to 4 to 16. And then here x equals to, from here, u minus 4, and then radical 4 plus x is simply radical u, dx is du. I hope this makes sense to you all. So now I have all the u variables here in our new integral, so we can easily integrate. Let me scroll down. That's better. Oh, that's better. Then pi as it is. Next step, definite integrals. First foil this radical u inside. So radical u is same as u to the power 1/2. Multiply inside, so that means u times u power 1/2 becomes u power 3/2 minus 4 times u power 1/2 du. Then the next step, take the integration. So pi as it is, integration of u to the power 3/2 with respect to du becomes u to the power 3/2 plus 1, which is 5/2, divided by 5/2 is same as multiplying by 2/5. I'm just flipping here. So 2/5 u to the power 5/2 minus as it is, and I have a constant 4, but when you take the integration of u power 1/2, it becomes u power 1/2 plus 1. It's 3/2, and divide by 3/2 is same as multiplying by 2/3. So then that 2 and 4 becomes 8/3 times u to the power 3/2, and put the limit u equals to 4 to 16. Great. So now put u equals to upper limit 16, put u equals to lower limit 4, and subtract these two values, means the value you obtain by putting u equals to upper limit and the value you obtain by putting u equals to lower value, means lower limit, and simplify. It turns out that the surface area is 3712 pi over 15. Great. Now we finish this section 8.2. Thank you.